Hello, Macoy. I'm going to be reading through and responding to your paper one in this video. The introduction of space travel to aerospace engineering. Aerospace engineering consists of the computational, technological, and structural aspects of the aviation industry. The field of study was set into motion at the dawn of the 20th century by pioneers of flight like the well-known Wright brothers. In the early stages of aerospace engineering gravitated around light and propeller-powered aircrafts. The aircrafts constructed during this time period were simple designs from very scarce resources. Why were the resources scarce? You mean they just didn't have a lot of money, maybe? But sparked one of the most rapid evolutions in a specific field of study. From the Wrights' first successful flight at Kitty Hawk, it took only 25 years before aerospace technology achieved rocket-powered flight in 1928. That's crazy. And from this technology, we were able to break through the exosphere and land humans on the moon. My question to history is, how did the field of aerospace engineering evolve to focus on space travel in addition to aviation within the Earth's most immediate atmospheric layers, stratosphere and troposphere? Lovely. Only one little thing did I notice there that I thought could be better. When you said the early stages gravitated around light and aircrafts, this is a real nitpicky thing, but I don't feel like everybody went to the aircrafts, which is gravitated usually means it was more like that was the only thing that there was to do in aerospace. So that's just a little piddly thing. Okay, the first step in dissecting this question is to stretch back to when it was discovered that technology used in avionics, that's a cool word, could be helpfully translated over to astronautics. A good starting place is in 1903 when Constantine E. something published his, quote, rocket equation. This equation, quote, concerns relationships between rocket speed and mass, as well as how fast the gas is leaving when it exits the propellant system's exhaust and how much propellant there is. That looks good. This guy was a founding father of rocket technology and a big part of accelerating the field of aerospace engineering into space travel. Others among him, so one little thing here, the rocket equation. See, I love the way you introduce the quote, but you need a little more something about what's meaningful about that. Before you go into he was a founding father of rocket technology. Often people talk about sandwiching quotes within the writing, right? And you have a great intro, but I think a little bit more kind of repeating this equation concerns blah, blah, blah. And then maybe it helps people to do X, Y, and Z. This guy was a founding father of rocket technology. Maybe like that. And a big part of accelerating the field of aerospace engineering and space travel. Others among him. Wait, sorry, no, I'm confused. This guy was a founding father of rocket technology. Yeah, that last part about who he is, that he's a founding father, seems like it belongs right at the beginning of the paragraph. Okay. Others among him, such as Robert Goddard and Herman somebody, also acted as the founders of rocket technology. You don't need to put founders in quotes because I think they really are the founders. That's probably a totally fair thing to say. I trust you. Others among him. I think maybe you meant to say something more like other rocket scientists included, or Robert Blah and Herman Blah. Yeah, I don't know why you have others among him. I don't think you need that. Anyway. At this point, rockets were at one of their simplest stages. The use of rocketry from 1926 to the end of World War II was somewhat experimental, leading to U.S. patents for 2- and 3-stage rockets using solid fuel, but mostly the cause of devastating bombings happening during World War II. Okay, so we had a paragraph. This paragraph started, and it's going to be about the starting people the people who really founded aeronautics. But now we're talking about World War II. I feel like maybe that should be a new paragraph. Anyway, the Nazis' early because it's confusing to me that you're talking about, and I think you're going in chronological order, in time order. This happened first, and then this, and then that. But it kind of feels like we're going back and forth. Maybe this is just me, but like early rockets, okay, rockets as warfare, and then back to, I don't know, I'll stop talking about that. Okay, the Nazis' early production of the effective V-2 rocket made it the most infamous and one of the only rockets used the entirety of the war by either side. As far as space travel goes, it was on the back of the minds of the engineers working on these weapons of mass destruction. It's in the back of the minds of the engineers. I like describing it that way. I don't know if maybe it could be a little bit clearer, but I like it. It was in the back of their minds. One interesting thing to note is that space typically comes to mind when thinking of rocketry. The term even involves itself in general space travel terms, rocket ship. However, this is the most recent evolution of rockets. What were rockets originally engineered to do? Were they a product of weaponry? And if so, how did they go from something so destructive to the foundation on which the giant leap for mankind was made possible? Or is it just a matter of time before rockets are weaponized in space as well? Evidence of this could be seen in the new branch of the US military, the Space Force. Okay, I love all of your ideas here, and I see how they connect, but I just feel like they could be a little bit better connected. Why am I feeling that way? Maybe by just really separating out, like, here's the paragraph about early rocket people. Here's the paragraph about World War II. Here's the paragraph about space travel. Like, I think it would be stronger just to separate those out a little bit more. Rockets worked well within the Earth's atmosphere, but propelling them out of the atmosphere was and still is much more difficult. By the way, I love that part about space coming to mind with rocketry. Like, I never thought about it before, but that's cool. Rockets worked well within the Earth's atmosphere, but propelling them out of the atmosphere was and still is much more difficult. The power of the rocket, the precision of switching stages, the trajectory of the rocket, and other factors all differ from launching a rocket within the bounds of the atmosphere. And with the lack of technology, computers were not advanced enough to simulate what will happen to a rocket under certain circumstances. With the lack of technology? So do you mean like before we had sophisticated computers, we were not able to simulate what will happen to a rocket? I think that is what you mean. This unfortunately led to multiple flight tests ending in horrific explosions, in some cases only a few seconds after the rocket left the launch pad. But then in 1957, the Soviet Union successfully launched a Sputnik satellite into orbit of the Earth. This inspired the United States to fast-track their space program out of panic. This part of history is commonly known as the space race. The U.S. never reached a successful launch. I was just thinking, like, it's been quite a while since you quoted something. But as I look back, it does feel like you're talking about some kind of common knowledge, probably some common knowledge stuff. I don't feel like you need to cite the existence of Sputnik or when that happened. The U.S. never reached a successful launch of an artificial satellite until 1958 when Explorer 1 was launched, quote, aboard a four-stage version of the Redstone missile. The Redstone missile is actually a short-range ballistic missile that can be modified to carry into space. Are you supposed to carry something into space? Maybe not. I'm not sure about that. This missile was then named Juniper C. That's funny. The story of Juniper C is a really good example of the use of technology from what the aerospace industry had performed and had already perfected in Earth's atmosphere in the field of aeronautics and space travel. Okay, back up. The story of Juniper C is a really good example of the use of technology from what the aerospace industry had already perfected in Earth's atmosphere in the field of aeronautics. Yeah, you can do that better. I think one thing that's happening is there's just a lot of words. From what the aerospace industry had already perfected. Yeah, I'll leave that to you. But revise that. Although there was never any solid plan to incorporate technology designed for ballistic use to space travel, aerospace engineers and physicists did this anyway. Just 2 months prior to... It's interesting. The idea of the fact that happened. Like, it comes out different places in your writing, which I don't know if that's a bad thing, but Just 2 months prior to the United States launch of Explorer 1, the Soviet Union had a second major breakthrough in space travel. On November 3rd, 1957, Sputnik 2 was launched, and aboard the rocket was Laika, a stray dog. I remember the name. Although the results of the mission were tragic, Laika proved that living things could survive the force of gravity felt upon entering space, and also the weightlessness of being in space. This event was arguably one of the biggest breakthroughs in space travel and a huge opening for the field of aerospace engineering to expand into. What was a huge opening for engineering to expand into? That can be much clearer. The limits of what was known broadened. Technology could now put living things in orbit around Earth, although this was nowhere near perfection upon the launch of Sputnik 2, it was a really good starting point. Wait, what was a really good starting point? Yeah, you're getting a little unclear here. Aerospace engineering's next biggest milestone was again by the Soviet Union in 1961 when they flew the first humans into space. This was Yuri Gagarin. His flight, quote, on April 12th, 1961, lasted 108 minutes as he circled Earth for a little more than one orbit of the Soviet Union's Vostok spacecraft. You incorporate your quotes well. This one, though, I would say, like, not a thing you need to directly quote. You can, if you're just talking about facts that you got from a place, you can just mention the source. There's nothing, and I don't see anything, the reason I'm saying that is I don't see anything particularly special about the way this is, and these numbers are probably something that, like, are common knowledge, basically, that everyone agrees on. Okay, and then in 1969, one of human life's greatest achievements, I think we would just say one of humans' greatest achievements, happened. Humans were able to set foot on the moon. For generations of aerospace engineers, this great event acts as a projection of the research they did to space travel and astronautics. Acted as a projection? Acted as a projection. So when they saw that, I don't think that's quite what you mean to say. The field of aerospace changed very quickly following its arrival. As older technology was repurposed, aerospace engineering played an important part in the wars that were fought and the history that was carved into the fabric of humanity. One thing that still tingles the question, well, you'll fix that. Okay, how did aerospace evolve into space travel as well as aviation in the confines of the atmosphere is whether or not it actually did evolve. As was mentioned before, we got a capital M there. Most of the technology that was used to make the first breaks in space travel were repurposed technology that had already been mastered within our own atmosphere. However, this is not meant to disparage the achievements that aerospace engineers have gained. Well done. Well done. Your writing is, sorry, let me check and see how long our video is. Okay, it's a little bit of time. Your writing is strong. I do think, though, like, the biggest issue is looking again at your organization and thinking how that could be a little clearer. Because I do feel like I said, sometimes you're kind of jumping around and repeating your jumps from aviation to aerospace. So hopefully that will be helpful with your revision.